right, guys, to complete the following assignment, you're going to need this paper I gave you in class. And then another piece of paper. I may have a purple paper, but just notebook paper is perfectly fine too. You're going to need scissors, glue, a pencil, and a calculator. So the first thing I'm going to have you do is I want you to take this and I want you to actually pause the video. I want you to cut out each of these shapes and don't cut off the name of it. So cut around it, but don't cut the name off each shape. So I want you to pause the video real quick and cut around each of the shapes. Don't cut off the name. All right, now that we got all of our shapes cut out, at the top of your paper that you're going to glue them onto, I just want you to write area. Because today we're going to review all the area formulas for different shapes because we're going to use them in this chapter also. So we're going to start with an easy one. I'm going to start with a square. And what you need to do is turn it over and right where the word square is, and only where the word square is, you're just going to put a thin line of glue or tape if you have tape. Okay? So that when I stick it down, okay, I can create a flap like this. So see how that works? All right, so we're going to talk about a square first. So the formula for a square, we're going to write it on our flap. So the area formula for a square is length times width. Or some people like to say side squared because you multiply the sides of a square. So I'm going to draw a square on here. Remember, a square has 4 sides that are all the same length. So I'm going to put those lines on there showing they're all the same length. And that they have 4 90-degree angles inside of them. And I'm going to say that this side is 7 inches. So that means if this side is 7 inches, so is that side and that side and that side. So I would say area equals length times width. And I always like us to write down the formula because, again, the more you write it, the better you're going to remember it. And then I'm going to substitute in my numbers. So my length and width is the same. So I'm going to say 7 times 7. And then I'm going to say 7 times 7, that's 49. And we're talking about area. So that's inches squared. Okay. So there's my square. All right, let's do the other easy one next. So let's do rectangle. And again, same thing. I want you to take your shape, flip it over, and just put a bead of glue or a line of glue or tape, whatever you have again, just where the word rectangle is. We're going to flip it and stick it. And then we're going to make a little crease, hold it up. All right, so now we're going to do the area formula for a rectangle, and we've done these before. So the area formula for a rectangle is just like the area formula for a square. We're going to say area equals length times width. I know some people like to use base times height, and that is perfectly fine too. You use whatever is more comfortable for you. Okay. So I'm going to draw in a rectangle here. Remember, we know a shape is a rectangle if the opposite sides are congruent, and that it has 4 90-degree angles. That would signify a rectangle. So I'm going to say that this rectangle is 3.1 feet wide by 7.4 feet long. So if I was trying to find the area formula to this, I would say area equals length times width or base times height, again, whichever one you prefer. And then I'm going to say A equals, and I'm going to fill them in, and it really doesn't matter which order you put them in because they're actually the exact same thing both ways. So 7.4 times 3.1, because remember we can multiply in either order. Okay, and then I would say my area equals, and that's when I might want my calculator. So I have 7.4 times 3.1. I find out the area of the shape is 22 and 94 hundredths feet squared. So I have my rectangle formula and an example. All right, let's try another one. Let's try triangle next. Okay, so I'm going to take my triangle Again, I'm just going to put the glue where it says triangle. I'm going to stick it on and create my flap. Okay. So we know a triangle is any three-sided figure. Remember, there are a couple different types of triangles. There's scalene and isosceles, and what am I missing? Scalene, isosceles, and equilateral. And then we can also name an triangle by its angles. Remember, this one would be a right triangle because there's a right angle down in this corner. But there's also, again, equal angular, and then there is, I can't remember the other one. All right, anyways, maybe it'll come to me as we work. Okay, so my area formula for a triangle is area equals 1/2 times the base times the height. Okay, which makes sense because for a rectangle, remember we said the formula could be base times height. And if I cover up half of my rectangle, so if I drew a line right here, I'm going to cover up half of it with a ruler. Okay, a triangle is formed right here. So half times base times height makes sense. Or some people like to use the formula base times height divided by 2. So again, it's up to you which formula you are most comfortable with, probably whatever your teacher taught you last year. I know growing up, I was always taught 1/2 times base times height. I know more and more people are using base times height divided by 2, so I'll probably use that here today. So I have my triangle. Okay, and to figure out my height, I always look for my right angle. That right angle will tell me my base and my height. So if I gave us some measures, let's say I said this was 8 inches, I said this one was 4 inches, and I said this one was 10 inches. One of these units of measure we're actually not going to use because it's not important. We always look for our right angle to decide our base and our height. So if I were doing this, I would say area equals base times height divided by 2, or 1/2 times base times height, whichever one you like better. Then I would say, all right, my right angle is right here. So this one is my base and this one is my height. But again, it doesn't really matter if you switch them. So I would say 8 times 4 divided by 2. And then I'm going to plug that all into my calculator. So 8 times 4 I know is 32, and 32 divided by 2 is 16. So I know my answer here is 16 inches squared. All right, let's do a parallelogram next. So we're going to find our parallelogram. Again, put the glue on. And a parallelogram, and this would be the same formula if you had a rhombus. Okay, a parallelogram has opposite sides that are congruent, and it has 4 sides. The opposite angles are actually also congruent, but no 90-degree angles this time. So it's like a rectangle that's kind of been pushed on its side, like it's starting to fall over. Okay, and the area formula for a parallelogram, let's write it on this flap. Area equals base times height. Now this is where we have to be really careful. The height is what we call the altitude. It's how tall the parallelogram is. So this is really going to be deceiving for you. So here, let's say we said that this was, we're going to keep them easy numbers, 5 inches and 7 inches. Okay, this right here does not mean my height. You will see a dotted line coming down from a parallelogram, and you'll see a little 90-degree angle mark inside of it. Inside of that, I'm going to write 4 inches. Okay, your height in a parallelogram is your altitude. Again, whenever you're dealing with height, look for that 90-degree angle. The 2 lines that make up that 90-degree angle will tell you your base and height. So here's my 90-degree angle. I'm going to use a little highlighter here. It's made up of this line and this line right here. So I'm going to say area equals base times height. Oh, here's my 90-degree angle. It's made up of the line that's worth 7 and a line that's worth 4. So my area here would be 28 inches squared. So be careful again. Your height is made up of the 2 lines, or the 90-degree angle is made up of the 2 lines that form the 90-degree angle. That lets you know what your base and your height is. It's a little bit tricky. Right, the next one we have is a trapezoid. Right? So a trapezoid has 4 sides, and the only characteristic a trapezoid has is that you have to have opposite sides that are parallel, and I'll show you how we would identify that. So you would see some arrows that's showing that those are parallel lines, and that's how we would identify if something is parallel or not. So the trapezoid formula that I have always grown up using is 1/2 times height times base 1 plus base 2. So that's what I tend to use. I know some people say height times base 1 plus base 2 divided by 2. That works also, but it's really hard for me to break my old habit. So lots of times I use that top one. If you like the bottom one better, if that's what's familiar to you, then please use that one. So here's my trapezoid. I'm going to give it some measures. Let's say that this one is 12 feet. Let's say this one is 8 feet. Let's say this side is 6 feet, and this side is 6 feet. But this is another one where we have to look for an altitude, a 90-degree angle. Okay, and I'm going to say my altitude this time is 5 feet. I'm going to say area is 1/2 times the base, times the height, times base 1 plus base 2. Okay, my bases are always the ones that are parallel to each other. So area equals 1/2 times, well, the bases I just said are the ones that are parallel. So that would be 8 plus 12. And the height, that's my altitude one. So I look for that 90-degree angle, the one that's 90 degree with my bases. So that's going to be the 5. The 6 and the 6 actually don't matter here unless I was asking you to find the perimeter of the trapezoid. So I'm going to say, in my calculator, I'm going to say, remember, order of operations first. So I'm going to say 8 plus 12 is 20 times 5 times 1/2. And I find out the area of this particular trapezoid is 50 feet squared. All right, last one is that of a compound figure. And we're not going to do too much with this one quite yet, but this is the whole reason why we need to learn these formulas, is because we're going to be doing compound figures with semicircles and quadrants, or sometimes a full circle. So a compound figure is when you have 2 figures that make one shape. So in this case, I can see that this is a compound figure with a rectangle and then a triangle at the bottom. So how do you find the area of a compound figure? Okay, so you're going to find the area of each shape then add them all together. So there's no fancy formula for a compound shape because all compound shapes are different. So what you would do is, in this case, I would find the area of my rectangle, I would find the area of my triangle, and then I would add those 2 areas together to find my compound figure shape. And we're going to be talking about those when I see you next. All right, that's it. Try the practice questions in Schoology.